In this module, we're going to cover the bond. First of all, it's important to know that a bond changes in price over its life. So here we have a February 2006 bond that was issued in 1986. So it's a 20-year maturity bond, and it has a coupon of 9.375. And as you can see, in 1986 has a price of 100, and as time goes by, the price changes. The price goes up to 120, then goes down to 95, 96, goes back up to 130 something, and then at maturity should go back to a price of 100 just because they paid par value, which is 100 at maturity. So this is really important. The reason behind this is the fact that the price of the bond, or very simplistically, the price is equal to the cash flow discounted back at the rate 1 plus R. I mean, this would be a one-time period, but this is just to get our understanding. As interest rates change, the price changes. So when interest rates go up, the price of the bond goes down. And conversely, if interest rates go down, the price of the bond goes up. To understand the bond basics, we need to know that a bond is made out of the coupon rate, maturity in years, a par value, and then this bond is going to make a payment, a coupon payment of the coupon times the face value over 2, because it is assumed that a bond is going to make 2 payments per year, plus the face value at maturity. The quantity of bonds bought or sold is going to be measured by the total par value. In general, the par value is $100, and in Mexico you have CETES, and in the case of CETES, the par value is equal to 10 pesos. Now, if you have a bond that's described as a coupon 7.25% and the maturity is May 15, 2016, then you can call this bond for short as a 7 1/4 of May 15, 2016. In there, you're going to have several assumptions, like the par value is going to be 100, like it's going to pay coupons twice a year, and so on. Now, the trade date is agreed by the parties, and once they agree the trade date, then the settlement date is going to be the next business. This is how this would look, and these are the formulas to solve this. So now let's see them in practice. So imagine we have the following case. We have this bond that pays a coupon of 10%, has a yield to maturity of 11%, time to maturity is 20 years, and the payments are semi-annual with a notional amount of 100. This is going to be our bond. So here we're going to have that the par value is 100, the coupon is 10%, the yield to maturity is 11%, and the time to maturity, M, is equal to 20 years. Now remember that there are 2 payments a year, so that means in total we're going to have 40 payments. So this means that here T is going to be equal to 40, the par value is going to be equal to 100, and here the coupons are going to be 100 times 10% over 2, that means 5. So now what we're going to do is we're going to put everything into this formula to see what the bond price is. So we have all the values, and then this formula is going to give you a closed form solution. So it's going to be basically 100 times C, which is 10%, over 2, over the yield, it's going to be 11%, again, over 2. And then now 1 minus 1 over 1 minus 11% over 2 times to the power of 40. So this is the coupon part. Now we need to discount also the par value. So it's going to be, as you should know, 1 plus the yield. So here it would be 11% over 2 to the power of 40. There we go. And this should be equal to, this is the formula way. Another way we can solve this is by using this formula here. Now this formula contains a summation, and this basically corresponds, it goes from t equals 1 to 40, so it corresponds to each one of these cash flows. So you have to discount this cash flow first, then number 2, number 3, number 4, and so on up to cash flow number 40. To do this, we're going to use Excel. So I have put in Excel here my cash flows of $5, the time period, so here would be T, that go from 1 up to 40, And then at 40, I'm going to have the coupon plus the par value. And then each one of these, I'm going to discount. How am I going to discount? Well, I'm going to use the formula from before, which is coupon over 2. And then I discount this to the power of 1 plus the yield over 2 to the power of t. So this first one would be 5 over 1.055 to the power of 1. Then the price I'm going to find for my bond, so I do the same thing for all cash flows, up to 40. And then the price I'm going to find for my bond is the summation of all these cash flows. So I get the same value than before, the 91.9769, which is this price. The next problem we're going to face is we priced the bond so far here at t equals 0. The next coupon payment was assumed to be equal to t equal 1. So that means that it could have been, let's say this bond was, instead of 20 years, at the beginning it was 30-year bond. And then now it's 20 years. And then at this date, t equals 0, there was a coupon payment. Of course, we don't consider it since it was already paid. Now, some days go by, and then t is going to correspond to something that we're going to call t equals today. And it's going to be in between t equals 0 and t equals 1. So t equals 0, I'm going to call it the last date. T equals 1, I'm going to call it the next date. And today, I'm going to call it settlement. And now the whole question is, what is the price today? To do this, we're going to need the number of days that go from last to next, and the number of days that either go from last to settlement or from settlement to next. And then it's going to be very easy, because the only thing we're going to do is say we have the price here at time t equals 0. So then the only thing we need to do is convert it or get the future value of that price so that I bring it to t equals today. So it's fairly simple, since I'm going to take, as it says here, the price at t equal 0, and then I'm going to apply this formula, which brings it to future value. So it would be 1 plus the rate, the yield over 2, since it pays semi-annual coupons. And then here I'm going to adjust for the number of days. So this NLN is going to be the total amount of days. Normally this would be around 180 days. And NLS is going to be how many days do I have to account in between t equals 0 and t equals today. Let's give an example. So the example is going to be exactly with what we had before. And in this case, I'm going to have NSN. So if I have here my line, I'm going to have from settlement to next, I'm going to have 35 days. From last to next, so this would be last to next. So all the way here, I'm going to have 182 days. And that leaves that from last to settlement, I had 182 minus 35. That gives me 147. So then I'm going to apply my formula, since I already have the price for my bond before. So the price was the 91.9769. Then I'm going to get my new bond price for today, which is the original price, the price at t equals 0, times 1.055 to the power of 147 over 182. And then I get my new bond price, 96.0417. Or if we round it, 96.042.